So hello, and you are very welcome to the Maths Guide on day one. So today is Sunday. Today is just going to be a little video day. You're not actually going to be doing any worksheets or any exercises today. So as any good guide, I'm just going to be introducing you to all the various topics. I'm going to explain to you what's actually going to be on the course and bring you through a path to understand all the bits and pieces that are on the course. So I'm going to do that in one moment, just to explain how the structure of this works. We're going to explore all the topics. We're going to run through them with kind of an overview to get an overview and understanding of how things work. And that'll help you to get a picture in general of the kind of the jigsaw that you're looking at before you start to put all the pieces together. What we're going to be doing then is we're going to be working through the topics, and then we're going to revisit the topics in this kind of a spiral pattern. We're going to be going around to different topics and then coming back around to the same topic again. Probably every fortnight, but sometimes there may be a couple of weeks where we investigate a particular issue a little bit more. But the idea is, as we go round and round, we're building our understanding, we're getting a more in-depth understanding, and at the same time we're integrating all the different topics together so you can see how it works together. So integrating just means putting everything together so that you can see what you're doing. Before I look at the various topics that we're going to be looking at, I want to just explain to you, for those of you who are on the course, those of you who are on the paid up course, how the revision and the exercises, the revision and the scoring works. So let's have a look at that. Okay, so the exercises are automatically corrected, and as you work your way through them, you'll get your various points until you've completed the exercise. So what happens is that when you start an exercise, you immediately go from no level at all to level 1. As soon as you answer any particular question, whether you get it right or wrong, you go to level 1. When you've got half of the questions answered correctly, you move on to level 2. And when you've completed the exercise, and it'll tell you that you've completed the exercise, you'll move on to level 3. Once you've completed the exercise, what happens is that you're automatically assigned revision. And the revision will happen in 1 day, 1 week, 1 month, and 6 months. So when you do your 1 day revision, which will be the day after you completed the exercise, you'll move on to level 4. When you do your next revision, you move on to level 5. You do the 1 month revision, you'll move on to level 6. And you do your 6 month revision, you'll move on to level 7. When you've done your 6 months revision, you will move on to level 7. And when you're moved on to level 7, you just stay at level 7. You've completed all of your revision and your level 7 is locked in. Now, just about scores. Different topics have different scores depending on how difficult everybody found them. So it's calculated automatically based on the difficulty of those who are doing the exercise. Will give you a particular score. And when you've completed the exercise, you get that score. When you complete your first revision, you will double your score. When you do your first week revision, you will double your score again. So now your score will be multiplied by 4. Similarly, in 1 month, you'll be doubled again. And in 6 months, you'll be doubled again. So overall, whatever score you had when you completed the exercise, you will have 2, 4, 8, 16 times that score when you've completed all of your revision. However, if you, let's say you get to level 3 and you miss the revision on the following day, then you go back to level 1. So you just pretty much have to start again. So you can't miss revision or you just go back to level 1. However, when you get to level 7, you're completed and you're locked in. So the reason you need to know this is, of course, because there's prizes. There's prizes for those who have the highest scores, and there's prizes just for completing the course. So if on May the 31st, is it 30th or 31st? I'll have to check that. Of the year that you're doing your exam, so you choose your exam, you've chosen your exam at this point, your exam year. If you've got a level 6 or above in 95% of the topics, you're considered to have completed the course. Okay, so level 6 means you've done your 1 month revision, and if you've got a 1 month revision or 6 months revision in 95% of the topics, you're considered to have completed the course. So of course this means that we'll need to finish the course by the end of April, so that your final 1 month revision will occur at the end of May. All right, so we'll be doing lots of exam exercises and things like that during May. So just a warning, when you get to level 6, it'll be locked in at the end of May. The system will kind of freeze it then at the end of May to figure out whether or not you've completed the course. However, getting a level 6, if you get a level 6 in a topic and then you go, oh no, I'm fine, I've got to level 6, I've done what I need to do for the topics, that won't work, because if you missed the 6 months revision, then you go back to level 1. So remember to not miss any of your revisions all the way through to the end. Okay, so there's more on the prizes page anyway about how to get prizes, but basically if you've completed the course, you get the largest chunk of the prize. I think at the moment it's about 70% of the prize for completing the course, for those who have completed the course. And the remaining prizes go for those with the highest scores based on what your score is. Okay, so that's exercises, revision and scoring. So let's go back and have a look at the topics that you're going to be doing. So like I said, we're going to be exploring all the topics and we're going to be revisiting those topics usually on every fortnight to build and integrate your understanding of everything. Okay, so where we're going to start is we're going to start with formulae, or formulas that you already know. For example, the area of a rectangle, you know, is the length multiplied by the width. So we'll be thinking about units, and when we try to find the area of various different shapes, there's only a couple of types of areas that we look at. So we look at squares, we look at rectangles, we look at circles, and we look at triangles. And when we're applying this to a particular problem, obviously the shape of different things aren't just circles, squares, rectangles, and triangles. So what you will be doing is you're going to be breaking bits up and just applying the formula that you have for the few types that you actually know. And the same will apply to volume when you're looking at cubes, cuboids, cylinders, spheres, and other prisms. Okay, so we'll be looking at formulae. We'll be looking at writing down a formula for the different types and substituting the values that we have in, and then applying that to particular problems. And we'll be figuring out how to do a problem with just one step, finding a square, multi-step. That's another different thing that we'll be looking at. Okay, when we've done that, we're going to be looking at doing that in reverse, where you're told what the area is and maybe what the width is. So if you're told the area of a square, you might want to reverse that and figure out what's the width of the square. So that's reversing for formulae, and that will lead us to equations, which we'll explain when we get to that there. Okay, so there's different types of formula. There's obviously this formulae with length and width and input and things like that. And there's ones where there's only a single variable. A variable is the thing that changes when we're looking at it. So for example, a square, there's just the width of the square that you have to worry about. That's what I mean by a single variable. But we'll look at that again. But the idea is we're going to be looking at types of things. But anyway, we'll be looking at the types of formulae that we have. We're going to be looking at practical problems that we can use with our formulas to figure out. We're going to be using practical problems involving money, which is going to lead us to talk about VAT. And we're going to be looking then at percents, decimals, fractions, and we'll be working our way through that. So this is something that you know something a little bit about already, but we'll be working in more detail about that. Now, with a formula, usually you're given, here's the width and here's the length, and work out what the area of this rectangle is. Or here's the width of the square, work out what the area of the square is. Now, sometimes when we want to predict the future, we're going to be looking at all the different possible inputs that could go into it. And when we collect things together to look at all the different possible values that we could put into our formulae, we're talking about sets. So we're going to explore sets then. And when you look at all the different values that you put into it and look at all the different values that you can get out of a formula, that's called a function. And a function describes a relationship, and we can picture that relationship. And a picture of that relationship is called a graph. So again, then we're going to be looking at types of graph and the types of data. Data are the values that you put into these, the values that are going to the sets of inputs, values that you actually have. So we're going to be looking at types of data and types of graphs. Okay, so again, don't worry too much if you don't understand this too much just yet. I'm just introducing to the idea that we're going to be working on a path. And we're going to start with formulae. And we're going to look at how those formulas become functions when we look at the sets of inputs that go into these functions. And we're going to work away with that. Then when we look at functions, when we're looking at the sets of inputs and the sets of outputs together, we're describing a relationship, and we can draw up pictures of those relationships. Okay? And there's different types of pictures of relationships, and there's different types of relationships that we have. So when you remember with the formula, we were originally, when we were looking at area, we only looked at a square or a rectangle or a circle and a triangle. And if the shape was something different, we broke it up into pieces so that we could call it a square, a rectangle, a circle, or a triangle. So similarly, we look at different types of functions. Functions that work in a particular way, that do particular things. And we're going to look at putting values into the function and getting values out of the function, which is exactly the same as putting a value into a formula, like the length and width into a formula, and you find the area comes out. We're going to be doing that with a function. And also, given the answer to the function, like for example, when you're told the area and you want to work out what the width of a square is, we want to work our way backward from the output to the input. And if you have a type of function, there's different ways that we can figure out what the function is and find out the missing pieces that we're looking at. So we will then be looking at specific types of graphs. And when we're looking at specific types of graph, that brings us to the topic of coordinate geometry of the line. Again, don't worry about what this means just yet. It just means a particular type of graph that we're going to be looking at, and we're going to be looking at it in detail because it's very useful. Then we're going to go back to functions. We're going to be looking at patterns, and we're going to be discussing patterns as a function. And then in terms of graphs, we're going to be looking at other graphs that aren't functions. So we're going to be learning how to read graphs well in terms of speed, distance, and time, things that are changing. So we're going to look how information is displayed, and you're going to look at how to interpret it, or how to read a graph, basically. It's how to look at a picture and understand what's happening. And as we work with looking at pictures and understanding what's happening, we're going to be talking about data, we're going to be talking about statistics, and we're going to be talking about probability. So that whole area of statistics and probability, I've got quite a lot to say about that. It's a little bit different to what you're used to in maths. So I'm going to discuss that in a bit more detail when I come to that, but we'll look at that when we get to that. Okay, so let's not look at that at the moment. Now, that was a particular path of information that we're going to be looking at. But as well as our particular path of information, we're going to be looking at all the little interesting things that we see as we go along the path. So we're going to be looking at properties of numbers. So a property of a number, for example, is whether it's even or odd. And whether something is even or odd depends on a few things. And then there's other interesting properties of numbers that we can look at and discuss. Similar to the idea of things being even or odd, things can be compounds, they can be prime, they can work together with other numbers in particular ways. So we're going to be looking at that. We're going to be looking at rounding numbers, which we'll discuss when we get to it. The highest common factor and the lowest common multiple, you've probably come across that before. We're going to be looking at powers. So it's the idea of multiplying numbers many times together. And as a result of that, we're going to be looking at the idea of very large and very small numbers. So up to now, you're used to dealing with numbers that you encounter in normal life. However, in science and engineering, you will be encountering very large and very small values, and you need to know how to read them and understand them a little bit better. As well as that, another area that we're going to be looking at is called geometry. Geometry just means to measure the earth. And measuring the earth, of course, is a very important topic, especially when it comes to land, really, the importance of land for people and how to measure things like that. But it became a topic in its own right. So again, this is one of the interesting things that you'll find along the path of maths that you can look at. And we're going to look at all the different skills that you can learn in order to understand how things are laid out. That might sound a little bit vague, but we'll get to it in a little while. Constructions is your skill in using pens and pencils in order to draw and create things. And then geometry is your skills in reading and understanding pictures and the relationships between lines and angles and things like that. Okay, so again, there's actually going to be a good bit of memorization in geometry. So learning things by rote is actually pretty important on occasion, and we will definitely be doing that in geometry. Of course, in order to memorize well, you first have to understand something. So we'll be going through to make sure you understand it, and then we'll be sure to make sure that we use the best ways to memorize. So I've got a few techniques for you that'll help you with memorizing geometry, and will of course also help you a lot in other parts of school. Then we'll be looking at the application of geometry to one-step problems. So the same as you do with formulae, you can work out something simple, then you work out it in a more complicated multi-step sort of things, and then you work it out in a big complicated area where you have to look at the problem and you have to cut it up into the different pieces, using the skills that you've learned in order to understand and work with that. Okay, so this is the general idea. We're going to go through that particular path. You're going to get an overview of everything that's going on. Then we're going to revisit that and get more skills and go in more depth and more details. But the idea about getting in-depth understanding of topics, but at the same time integrating all the topics together, is that you can understand how everything fits together and you get a jigsaw-like puzzle understanding of the whole picture. And I think that's really important, to understand the whole picture, because it helps you to understand why you're working with a particular skill in a particular area. So if you're a carpenter, it's a good idea to know what you're trying to build rather than just working on the particular skills of how to use a saw or a chisel or what types of wood you should use. And similarly in maths, you have to become very skilled at the various exercises that you have to do, but you have to also to understand what you're trying to achieve. And in order to do that, you need some intuition, and to achieve that you have to become very skilled at what you're doing until it becomes second nature. And when something is second nature, you begin to become a master at it, and that allows you to be creative. So as I've said before in previous videos, what I'm looking for here, what I'm hoping to do for you, is to give you the skills that you need in order to become a creative person, somebody who creates things in the world. And it doesn't really matter whether you do that in maths, engineering or science, but the mathematical skills that you will learn here will help you to understand relationships between things, and also to understand that you do need to build skills in order to become an excellent and masterful creator, which is what I hope you do become. Okay, so that's today. That's a little introduction to the course. This is just the overview of the path we're going to be taking. So we're going to be working our way through this path for a little while, and then we'll come back to the start, and we're going to start working on more detail, and then looking at application of it, and working with different topics together at the same time. Okay, so that's the idea. As I said, today we don't have any exercises to do, and tomorrow we're going to begin looking at formula. All right, all the best. Have a good evening.